Hey everybody, welcome to today's intro to K3s online training. Really happy to have you all on the line. As usual, we have quite a few people who registered, so hopefully quite a few can attend during the workday. We're really glad that you all made it. I do want you all to know that this session is being recorded, so you will receive the recording and the slides after the training. Just check your inbox, usually by end of day today or tomorrow, you'll receive it. We'll also post it online on YouTube in case for whatever reason you missed the email. So if you need a drop or you have to run to a meeting or something like that, don't worry, you'll be able to revisit the session. So as a way of introduction, my name is Matthew Shearer, I'm marketing manager here at Rancher. I help host these intro training sessions as well as our more advanced training on Kubernetes in the Kubernetes Masterclass series that happens pretty much every Tuesday. You can find all of those online on YouTube as well. I'll talk a little bit more about that in a minute. But if you do need a resource or you need a point of contact at Rancher to ask a question or try to find something, don't hesitate to reach out, Matthew@rancher.com, or you can find me on the user Slack just with the handle Matthew. And I'm happy to continue the discussion and answer any questions that you might have. But the person who's really going to be doing the heavy lifting today is Mark, our field engineer. Mark, are you there?
Yeah, I'm here. Hi, everyone.
All right. Well, I'll let Mark introduce himself a little bit more in a moment. But just some housekeeping items first. So we try to keep this session to about an hour, but we have more time scheduled if we need to. We want to be as responsive as possible to what you all want to learn. So if you have questions, please ask them. This is meant to be, discussion, informal class. It will be hands-on. There will be a lot of demoing, so you can see how K3s works and how you can get started with it and what you can do with it. So don't hesitate to ask a question. GoToWebinar has a cool question feature. If you want your question to be private for whatever reason, just let us know. Otherwise, we'll ask it aloud and answer it aloud so that everyone can learn from what you're curious about. And as I mentioned before, this session and all of our other trainings are free and posted on YouTube, youtube.com/c/rancher, and you'll be able to find just dozens of different sessions that we do on many different topics on containers and Kubernetes management there. We have a thriving community and a great place to continue to learn and ask more questions. I believe many of you are probably already using these two community resources, but if you're not, slack.rancher.io and forums.rancher.com. Slack.rancher.io is great for active participation every day. People asking and answering questions. Our engineers monitor there as well. And forums.rancher.com more for long form questions and product announcements and news and things like that. Well, as I mentioned, we also do more advanced training sessions that happen pretty much every Tuesday. Next week, it'll be on implementing a data management strategy. One of our partners is going to present using Rancher. And then after that, we'll talk about cluster lifecycle management with backups and migrations and disaster recovery and things like that. So a lot about automation. So check those out. These sessions happen every Tuesday. Again, they're posted online, but it's great to join if you can so that you can ask questions and hear what other people are asking. So now that all of that is out of the way, we can jump into the meat of the material. So Mark, I'm going to make you the presenter, pass the presentation to you.
All right. Okay, and so you should see my screen now, which has an agenda that I've set up for today.
Yep, we're good to go.
Great. All right. So a little bit more by way of introductions. My name is Mark Abrams. I'm a field engineer with Rancher Labs, and I've been with Rancher for a little over 12 months, and very, very excited to be working at Rancher. I'm excited to be here presenting today. I've been in the Kubernetes space for about 4 years and doing other things with container orchestration prior to that. I'm actually very excited about edge use cases for container orchestration. And so as you can imagine, K3s is right up my alley, and I presume many of you are here today because you're interested in that as well. So getting on with the agenda, what I'm going to do is I'm going to give you an overview of K3s and just kind of go through what it is and how we came to having K3s. And then I'll do an installation and an upgrade on some servers of K3s. We'll deploy it on ARM. And then we'll get into some other ancillary technologies, something called K3d, which is on the desktop. It's K3s in Docker containers. And then I'll also show you today K3os, which is a container operating system specifically designed with K3s in mind. And then finally, I'll show you how we can manage multiple K3s clusters and deploy applications. It's a lot, so I'll try and pack in as much as I can in the time that we have. So I'm just going to jump right in here. So from the overview perspective, what is K3s? So it's a lightweight certified Kubernetes distribution. And Kubernetes, so it was certified by the Cloud Native Computing Foundation, and it is, true upstream Kubernetes. It was built for production operations, and what that means, so there are other lightweight Kubernetes installations. There's some other ways that you can do lightweight Kubernetes. And so there's like micro-k3s, there's Minikube, and those are really designed for like single node clusters, whereas K3s is really designed for, the intent is to have a full-on HA Kubernetes cluster that you could use in a production environment, not just in a development environment. So we have compressed it down to a 40 megabyte binary. It's a single binary where Kubernetes is multiple binaries that need to get installed. K3s is a single binary, and it consumes about 250 megabytes of memory. And I'll show you the memory consumption during the demo as well. So as I just said, it's a single process, and we've integrated the Kubernetes master, the kubelet, containerd. So we're basically wrapping it all in one and just making it easier, simplifying Kubernetes. In addition, we've made it so that you don't need etcd. And the first iteration of K3s came with SQLite 3. And still, when you install it today, out of the box, you'll get SQLite 3, but you can use an etcd backend. You can also use a MySQL or PostgreSQL backend at this point. So there's a variety of ways to do it. When we released it, we simultaneously released for x86 and ARM version 7 and version 8. Version 8 is the ARM 64. So it's available. There's a lot going on with Edge and the ARM the system on a chip, and so having the ability to have container orchestration on an ARM processor is pretty cool. Also, it is an open source project, and this is everything Rancher Labs does is open source projects. So we have everything's open source. It's fully available. You can download the source code and modify it. There's no charge for the code or for the runtimes. There's no upcharge if you're an enterprise and you use it. It's all the same. Rancher products are things that we support, and over time, with usage and requests, basically, we end up supporting our projects as products, and they need to be robust enough to be supported as products, obviously. So a little bit more about K3s and what we removed. You may have also heard of our Rio project, and this actually came out of working with the Rio project, and the developers were, while they were working on Rio, they were saying, I wish I could just have the Kubernetes that I want to have, and I don't want all this other stuff. And so what's that other stuff? There's Kubernetes the model for sharing code in Kubernetes and for sharing new ways to do things is all in tree. And so there's a lot of stuff in tree in the source that you don't use when you're running Kubernetes. So there's, and then in addition, there's a lot of development and other things going on. So there are legacy and non-default features that get built into it. There are alpha features that haven't come out yet. There's in-tree cloud providers, so support for the cloud providers is right in the source, and in-tree storage drivers. And for cloud providers and storage drivers, you tend to, you know, depending on your enterprise, you might use several cloud providers, but typically you're not going to use them all. And so you end up with a lot of, you know, bloat in what's in Kubernetes versus what you're actually using. And then we also made Docker optional. So you can use Docker if you want, but we pulled out Docker because that's become a prerequisite for having Kubernetes. You have to have Docker installed on the server. And so rather than do that, what we wanted to do was have a container runtime that's just built in. So it's built in with the binary that you install as K3s. So all this, the compressed binary, compiling everything into a single binary, that creates a simplified installation of Kubernetes, and I'll show you that. SQLite 3 support in addition to etcd, so we added that. TLS management, if you've ever set up your own Kubernetes cluster, one of the things you have to do when you're setting up Kubernetes is to do your certificates. And so this just does it for you. So that's a nice feature as well. Again, goes to the simplified installation. Automatic manifest and health chart management. What is that? So what that is that there's a way with K3s to drop a YAML file, a configuration file, into a directory on the K3s server and have that propagate as if you did like a kubectl apply-f to that file. And periodically the system will go through and scan and see if there are any changes. But what it means is that you can get auto deployment. So on startup of an edge device, you can have something that's already set and ready to go, an application, all the components, the services, the load balancers, whatever you need for that can just be on start when K3s starts, your application is running. And then of course, we added containerd, we're using core DNS, we're using flannel, we're using traffic, which is not listed here, but we're using traffic for the ingress controller. So the architecture of K3s is actually very similar. If you go and you look up the architecture for Kubernetes, it looks a lot like this. You'll see on the master, you've got the API server, the scheduler, the controller manager, and the etcd database kind of is outside of that process box, and now it's kind of inside our process here. But basically, these are the component parts, right? So the master, the server in this case, looks a lot like the Kubernetes master, and that's because it is. And then the agent has the kubelet, the kube proxy, and the components that you would expect there as well. The big difference here for how K3s works with standard Kubernetes installation is this tunnel proxy. The tunnel proxy is a one-way communication from the agent to the server. And then once the tunnel is established, they can do a two-way communication. But it really simplifies the communication between the two in the sense that you really only need that port open for that one port open for tunneling, and that's HTTPS WebSockets. So you can just have these things talk without having lots of ports open and changing the attack surface on your cluster. So a little bit about the use cases we're seeing. Edge computing. Edge computing is, there's a lot that goes into edge computing. There's network edge, there's telecommunications edge, there's retail edge. So we're seeing K3s and interest in it on edge computing for a lot of reasons. And then embedded systems. So embedded Linux, there's interest in, hey, could I just have a device that comes with container orchestration built into the SOC and just ready to go? And I just wanted to connect up my component parts to make a cluster, and then deploy my containers and have it running. IoT gateways, so with all the edge devices, many of which couldn't run Kubernetes or K3s, they're still too small. But they send data and retrieve data from these gateways to the cloud or to some data center. And so these gateways are becoming a location for processing, for compute, and they can be used as compute, thus reducing the need to send data over to the cloud and reducing throughput, and it solves a lot of problems on the edge. CI environments. So this is an interesting use case because of the simplicity of K3s and the lightweight Kubernetes. You can spin these things up really quickly, run your builds, and then tear them down. And so it's a nice solution to have if you're using Kubernetes and container orchestration in your build environment. This is a nice solution to make that work without a lot of overhead. And then single app clusters. So when we build applications, we want high availability, reliability, scalability. And so even though we may not get the benefit of an HA cluster, having a single node that runs an application can still have some benefits, because if something does happen to that application, if it fails, Kubernetes is going to go in and just try and get it restarted again and right the system, basically. So what I'm going to do is move on to, that's sort of the intro piece. And now I'm going to move into a demo. And so we're going to get into the command line and actually just do an installation of K3s, and we'll upgrade it and just show you how it works for real. So the supported architectures are x86, ARM v7, and ARM64. I'm going to start the demo with an x86 processor and an ARM, two x86s and one ARM64. We'll get to an ARM v7 later on. First, I'm going to install by version. So I'm going to install a specific version of K3s, and then we'll run through the scripted installation and using systemd init script to start K3s, and then I'll do the same thing, only I'll upgrade it. Then we'll overwrite that. We'll install the latest version, because I'm going to install an old version first, and then I'll uninstall it. So that's where we're headed right now. All right, so, oops. Still got an old demo running here. All right. So what I'm going to do is I'm going to come in and I'm going to sorry, grab my notes here. All right. So what I'm going to do is I'm going to install. First, I'm going to log in to one of the servers. And I use a script to do that. I've got my servers built out on AWS. What I have here is I have this script, SSH connect, which is just a script I wrote, and then there's some command arguments that I can make. You can see my key is in there, and -i is which instance I want, and I've got a list of instances, so I'm using instance 0. So that's all this command is. It's just under the hood. It's just doing the standard SSH -i with my key name and things like that. So here we are. We're inside an Amazon instance. Let's do a uname -a, and we'll take a look. And you can see that this is an x86 server. So Now what I want to do is I just want to pull down K3s. So I'm going to pull down an older version. What I've got here is the curl command, and the curl command is saying be silent and fail silently. The F is fail silently. The L says follow links, and then I'm using this get k3s.io. That is the script, and that will do the installation of the systemd init script. And then I'm specifying which version of K3s we're going to install. So I'm going to install version 0.3.0. So you can see very quickly that comes down. I'm going to do a kubectl version. And we can see that I'm using version 113 of Kubernetes on both the client and the server. And then I'm going to do a K3s version. And you'll notice that it's the version I requested, 0.3.0. Whoops. And you probably noticed that when it pulled it down, it also told me that information, the version information. So I'm going to run an upgrade, and the upgrade looks pretty similar. So now I'm going to install version 7, release candidate 4. And I'm doing it on the same box. It's almost the exact same command. It's just the change of the version. So we're going to overwrite it. And we'll run the kubectl version again. Now, I got an error here because something changed in version 0.7.0. And the thing that changed is that we changed how the kubeconfig mode works. So in the version 3, it was open and anybody could access kubeconfig that could get in here, but we wanted to secure that. And so we set it up so that you actually need to set a command line parameter. Whoops. And in this command, you can see I did the exact same command. I installed version 07.0, release candidate 4, but I added an install K3s exec line. And the first parameter is write kubeconfig mode 644. So I'm opening this up to be able to be used by other users of the system. How you secure your kubeconfig is probably dependent on your enterprise and the mode of security that you need to use for that. But that's the only argument that I added, and you can see where we started K3s again, and now we can run kubectl version, and now I've got an upgraded version of Kubernetes to 114. So let's do one more thing. Let's just pull down the latest and see what that is. So you'll notice I didn't specify any version here. I also didn't specify my kubeconfig mode. So if I try and run this, if I use sudo, I would be able to do it. And I will need to use sudo. And now we can see I'm still at 114.6. Let's look at the K3s version. The latest is version 0.8.1. So finally, you may have noticed that when I was doing the install, it actually told me about this uninstall script here. And so now I can just run that script, and that will uninstall K3s. So, whoops. There is no K3s. So simple as that. We've installed it. We've installed different versions. We upgraded it, and we removed it. So now what I want to do is actually show you a multi-node cluster. Let's go back to our presentation. So I just want to run through, before I go through each section, I just want to run through what I'm going to do so you can follow along a little easier. So multi-node clusters. So the process is that we're going to stand up one server as a K3s standalone server with no agent. So right now, that the way I installed it the first time, it actually was a single node cluster. It had the server and the agent all in one. I'm going to install it this time as just the server. We'll add another parameter to the command line, and then we'll install a couple of agents, and then we'll have a multi-node K3s cluster. So when I do this, I'm gonna do the server will be x86. I'll have one node x86, and then I'll have a second node that's an ARM node. And we'll see a little bit of difference here, and we'll see the nodes come online. So we're already logged in here. So grab the control panel. The GoToWebinar control panel is hiding part of my screen. There we go. All right. So here's our curl commands: be silent, fail silently, follow links, disable agent. That's new. So we're gonna disable the agent. This is gonna be server only. We've got our kubeconfig mode. I also added TLS SAN. So this is gonna write the IP address. This is the public IP address of this server, and this is gonna write the public IP address to the certificates so that the other agents can actually access it properly. So we now have K3s, and if I do K3s, if I do kubectl get node, it doesn't show me that it doesn't even show me that the agent is here, that there are no agents. It's only the server, and it doesn't see the server. But K3s is installed. We don't see any agents yet. So let's install an agent. I'm gonna, so the top one is my server, and I'm gonna run another command, and I'm gonna install the agent. Now this time though, when I install the agent, so first of all, I need to log into my second box. Running my little script again. Oops, I need to cd into and let's do a uname on this. This is another x86 box. And what I want to do is connect this to the other. So we will, what I need to do is I need to export a node token. And the node token is sitting in a directory. When K3s started up, it's sitting in a directory on K3s. So I'm going to grab that. And actually, I need to transfer it to this other box. So I'm saying create the command that I'm going to use on the agent. And this is just a little script I wrote, a little inline script, because then I'm going to take this and I'm going to make that an environment variable over here. And now I have a node token available. And so now I'm going to, instead of pulling down the init script, I'm just going to install K3s directly. So I'm just going to pull down the binary from the releases page. And no reason in particular other than just to show you that I can do this. And once I pull it down, I'm actually going to change the mode and move it over to the bin directory. And now I can actually run the command to connect it. It's the k3s command to connect it to the server. So let's do and we should see in a moment that this node will be connected to the master node. While that's thinking about it, I'm going to open up yet another terminal. So let's see. We may have to check our logs and find out what went wrong. Oh, CRT not found. That's my address changed. Well, it looks like I have not set up my networking properly from this server. This is interesting. All right, I'm gonna skip on to the next section. We can come back to this if we have time. But it looks like I've got an error in the fact that I actually cannot access this IP address, which I believe to be the IP address of my server node, and my agent node can't reach it. Obviously the server and the agent need to be able to reach each other. And as I said, the agent needs to be able to reach out over HTTPS. I'm doing this on Amazon, and there's a good chance that my security group is not configured properly to allow me access. So I'll have to check that out. So let's keep going. There's lots of other things we can look at, and then we'll come back. If we have time, we'll come back. We'll take a look at that. So let's look at K3s for the edge and ARM devices. So I'm going to put K3s on a Raspberry Pi 3A+. And the specs for the Raspberry Pi 3A+ are 512 meg of RAM and quad-core ARM V8 processor. I like to use the A+ because it is small, and it really sort of highlights the fact that we can run Kubernetes in these very small system on a chip and SBC boards. So I'm gonna run it here, and this device is actually here with me in my office. So the process is going to be I'm going to install via the script Raspberry Pi device on that device. And then we'll run the server, we'll do some stuff to view the resource utilization, and then we can uninstall it and go on from there. So let's clear out this one and this one. And we'll do so here I have my, let me do a uname-a so we can see what it is. Same thing here. I'm gonna actually install the latest version. I'm gonna use the right kubeconfig mode, and I'm gonna install it from script. Now this takes a little bit longer. That's the nature of the small device with less power. So while this is running, let's take a look and see, are there any questions that we might answer while this is getting set up? Let's see.
Yeah, Mark, do you want me to just read the questions aloud, or you just want to go in and check them out?
Yeah, so I see the first question is someone has an error. Let's see. Presentation is cut in lower part. Now it's okay. Sebastian. All right, Sebastian says, I'm running K3s with one master Raspberry Pi and 2 agent Raspberry Pis. Can the server node be made redundant? For example, failover in the case of the master Raspberry Pi goes down. So we are working, actually, that's a good question. And it's a question that a lot of people have, Sebastian. We are working towards a generally available release of K3s. As you know, this is still not GA. And the generally available release will have the ability to have HA clustering. And I'm not sure exactly how that's going to look. Right now, you can get HA with a single node. You can get failover in your data plane with a single node by connecting to an HA database. So you can just wire it into an already HA data store, and that will give you failover on the data plane. It does not, however, make it HA in terms of Kubernetes if the master goes down. And so that's something we're working towards, and I encourage you to go and get into the Slack group, go look at the forums, look at the issues on GitHub, and follow as we get ready to release the generally available version, and give us feedback and insight, and you know, test it out, let us know how it goes. All right, so here we go. I've got my environment back. I'm gonna switch back over to the demo, and we're gonna pull up another window here. In the top window, I'm gonna run htop. And htop is, it's like top, but it just gives me a little bit more visual information. I kind of like that little graph up at the top. And the reason I like it is that everybody can see sort of what's going on and how much usage. You can see there's actually a lot of utilization, and the cores are kind of getting hot periodically, and you know, in terms of just loading up, there goes number 3. And down in the memory, you'll see that there are some green bars, and the green bars are the used memory pages. The blue bars are the buffer pages, and the yellow bars are the cache pages. So we're actually using quite a bit of memory right now. And usually when I start it up, it's only about halfway, but I think we still are going to have enough to continue running this demo. So I'm going to split it again, and let's see. Step out of that for a moment. Whoops. What I'm doing, this is iterm2, and it allows me to run the same command in multiple places. And I should be able to stop broadcasting on this one. We'll run htop again here, and then here we'll cd into dev k3s training, and we'll SSH into that box. Okay, so now we're into both. And now we'll move on to what I want to do is show you in the Raspberry Pi. This is a Raspberry Pi, as I said. I want to show you a deployment on the Raspberry Pi. So I have here, and we actually want to stop looking at both here. Toggle broadcasting. I have here, let me show you an Nginx YAML, and I'm going to open that up. We'll take a look at that. Oops. You can see the memory went down to about half. So everything's kind of settling in. And I'll show you this Nginx. This is just a very simple Nginx file. You can see it's a Kubernetes deployment. And I have a replica of 1. I'm going to change that to 3. And there's nothing else really special about this. Actually, first go around, let's do it as 1, and then we'll do it as 3 later on. So that's what we're going to apply that. Oops. And you'll see the load on the server goes up a little bit. We'll keep an eye on things here. So my Nginx container is creating. While that's doing that, I'm going to start getting ready the next command, which is that I'm just going to delete it. And we're going to put it in the manifest. I really just did that to show you that you can. So what's going on here? There we go. We've got an Nginx deployment running. Okay, so let's delete that. Now we'll go in and we'll change this to 3. And then I'll copy that over to the manifest directory. So I'm copying the Nginx YAML, the one we just edited and made replicas of 3, over into the Rancher K3s server manifest directory. And then we'll just keep an eye on that. 3 containers creating. Keep an eye up top. Now we have containers running. I have three running, and you can see that not a lot of memory is being used, right? This is, now these aren't, these are not going to be high CPU processes, but I still have plenty of memory left to run other things. So this is kind of, I really like that we can have Kubernetes on edge devices, and I'm sure many of you are excited about that as well. I'm going to switch contexts again, and I want to get into K3d. So K3d, we did this, we did the deployment. So what I did is I took the standard Kubernetes approach, and then I showed you the K3s capability of using, both standard K3s and by the manifest. K3d what I want to do is show you how to create and destroy clusters in Docker containers. And this is just like crazy simple. If you ever went through Kelsey Hightower's Kubernetes the hard way, or if you're familiar with that GitHub project, this is like the exact opposite. Like and it's just crazy how easy it is to get cluster orchestration running using K3d. So we can create, by default, K3d will create a single node cluster, but you can also do some other things with it. You can do a lot of other things with it, but I'm going to show you the single node, and then I'll show you also the multi-node cluster. We'll create a cluster with three workers. So let's get out of here, and let's just close up this. We'll close up this one, and we'll exit out of here. So all right, so K3d, first of all, I'm on a Mac, as you can see, and K3d is installed via brew. If you want to install it on Linux, that's easy. You can pull it down from the GitHub page for K3d. If you want to install it on Windows, right now you need WSL2, and I'm not really sure that the outcomes of running in WSL2 is, I think that's still Windows. I'm not sure the state of WSL at this point. But so there it is. I've got K3d. I've got it ready to go. And I'm going to do K3d create. And this is just going to create me the default cluster using K3d. I need to run this kubectl command because I have other kubectls in play right now. So we're going to run that. And then we'll get the cluster info. So I have a small Kubernetes cluster running. And I can list out the clusters that I have as well. So let's do a K3d. Let me do show you the available commands. So there's a bunch of commands you can run here: create, delete, start, stop, things like that. Really great for local development. So we're going to do a K3d delete -a. So we're just going to delete all clusters, and then we'll run another command, and we'll actually create K3d create --name, and we'll give it a cluster name, cluster demo, and then we'll do 3 workers. Again, we're going to grab this command to get our kubectl. There it is. And now if I do a K3d list, so I have 1 master and 3 workers running in K3d. So another thing I'd like to show you is K3OS. K3OS is the operating system. It's the container operating system that was designed for use with K3s and edge devices. So what do I get by using K3s? So it supports multiple architectures, just like K3OS supports multiple architectures, just like K3s does. So on x86 and on ARM, you only need to, it only runs the minimum required services. So it's a smaller attack surface, greater security. You may be familiar with Rancher OS, another container OS that came out of the Rancher Labs. And we have enterprises that use it because it really goes through their security. policy and protocol and vulnerability scans very quickly and very simply. It doesn't require a package manager. So and this actually is interesting, right? Because we're so used to saying apt-get or yum install, and here we're just saying, hey, run my container. That is your package, right? Run my Helm chart. That's the thing that I'm running. So Helm is a package manager for Kubernetes-ish, and that'll work just fine with K3OS. K3OS also models infrastructure as code, and we'll get into that a little bit more on the next page, because there are about 7 different ways that you can install K3OS. So you can do an interactive installation. So you can load the ISO and then run OS config, and that will configure the system to be a K3OS system. You can do an automated installation using kernel command line parameters. You can do a bootstrapped installation. So there's a script out there that will, if you have a block device mounted, you can install it to a block device. You can use grub make rescue to remaster the ISO. So that's a utility. And you would obviously need to do that on a system that has access to grub and grub make rescue. You can do a takeover installation. So this is interesting. You can get into an existing Linux system, download K3OS, and then run the install sh script with the takeover flag and whatever other parameters, which are similar to what's in the command line. It's essentially the same as what you would do through the automated one, only you're doing it as parameters to this script. And then when you reboot into K3OS. And then you can do the ARM overlay, which is configuration that you set in the config.yaml and using the root file system. Now, they all have the ability to use cloud config type configuration as well. I'm going to show you a Vagrant installation, Packer Vagrant installation of K3OS. I've also done an installation of K3OS on a Raspberry Pi using the takeover method. So there are lots of ways, and I'm just going to show you one of them today. So let's clean this up, and we'll let's see, where do we want to go? VBox. So I have here, actually, let's just open this up. This may be a little bit harder to see, but there's a few files in here. So I'm going to start with the Vagrant configuration file. So this Vagrant configuration file, I'm creating I'm going to use Packer, and I'm going to direct Packer at this file, and Packer is going to create a virtual box for me. And what it does is it starts up Packer with a standard box with a standard ISO, and then it's the standard K3OS ISO. And then I'm going to enter these boot commands, and these boot commands will actually configure it to restart. If you just run the ISO, and then you shut it down, any changes you made, obviously, they're not going to be there. So this will actually make it so that my virtual box is permanently running K3OS. All right. And then I'm going to run Vagrant, and this Vagrant file is really boring. This Vagrant file basically says, go get the Packer virtual box. So we'll go here. So the first we want to do is run Packer And let's see, this pulls up the ISO. Now I put some pauses in here, and these pauses are to give time. There's a timing issue. I could all these commands that I showed you in that command string, and it's typing them now. All those commands, there's a timing issue, and you have to get the timing right. So when you enter a command, you have to pause and wait for the system to do whatever it needs to do. And that's just kind of a Packer build thing. So here we are, we're installing K3OS. And then VirtualBox is going to restart. In the background, you can see that it's also here, type the boot command, and that's what took so long. And there we go, we're back in, it restarted. And once this comes up, it'll shut down. It's waiting for SSH. Once that comes up, SSH is ready. It's going to shut down the machine, and then we'll run Vagrant to get it installed, to get it up and running. Almost there. Got an OVA out of it now. If you're not familiar with Packer and VirtualBox and Vagrant, Packer is a tool to build images. VirtualBox is a local virtualization from Oracle that you can use on pretty much any operating system, any OS, yeah. And then Vagrant is a way to run those images inside of the VirtualBox. So we're going to do a Vagrant up. And this is actually starting that virtual machine we just created. It's taking that image, starting it as a virtual machine inside a VirtualBox. Once that's done, we'll do a Vagrant SSH, and you'll see we're in the K3OS. Almost there. So the red at the bottom, it says the guest operating system could not be detected. VirtualBox has the ability to put some add-ons in there that will sort of work with the system, the underlying system. It doesn't really know much about container operating systems, and so I couldn't really find a way to tell it about the guest operating system being a container OS or specifically K3OS. So I get this error, and that's just part of doing it in Vagrant, I guess. So let's do Vagrant SSH. And here we have K3OS, and K3s is installed. I think it's an older version, yeah. There we have it. So once you have all these Kubernetes clusters, and especially with the trillions of edge devices that are going to be out there at some point, how do we manage all these Kubernetes clusters? And this is what Rancher has become really good at. We do fleet management, multi-cluster management, we call it right now, of devices in different clouds, on-prem, different data centers. Doesn't matter if it's upstream Kubernetes. We can help manage it. But that is going to become like this big problem as we move Kubernetes onto edge devices, and as it moves out to the edge. And you think about, if a warehouse has 600 edge devices, and maybe it's 600 that are some sort of connected to a cluster. Maybe it's only 50 clusters, but then how many warehouses do you have? And you know, the scale and magnitude of edge and managing edge is very large and very interesting. It's a very interesting problem. With Rancher, what we have is the Rancher management server, which runs on Kubernetes. RKE is the Rancher Kubernetes engine. It's a distribution of Kubernetes. Both those products are also open source products. They're projects, but they're actually products that we can support. But underneath those, you need to manage fleets of clusters on the edge, gateways, cloud, CI builds, on-prem, wherever all these things are running. That is something that we're working on. There is something in the works for fleet management in addition to the multi-cluster management that Rancher is producing. So I think I'm gonna stop here, and we'll maybe take some. I'm gonna take some questions, and maybe Matthew, if you can read the questions, that would be really helpful.
Yeah, no problem, Mark. And thank you so much for taking us through that, putting the demo and slides together. I really appreciate it. So there, right now, there is just the one question that you saw from about it looks like spinning up installing a new K3s version, and it actually, I think it'd be easier for you to just look at it.
Sure.
Because it's separated over a couple lines.
Okay, let me see. I cannot find systemd or OpenRC to use as a process supervisor for K3s. So that sounds like an operating system after doing this command. Arcadius, I'm sorry, I'm not sure how to pronounce your name, but the question looks like it's from Arcadius, and the problem, it depends what operating system you're running on. So K3s will run on Linux, on x86, and ARM right now. If you want to run K3s on a non-Linux device, then you will need something like K3d or K3OS to run it. And I don't know what operating system you're running on, but I've seen similar issues on the Mac.
He did, Arcadius did just post his operating system. It looks like he is using Linux, and he put.
Yes. Okay.
So if you can see.
Let's see. Linux, yes, 600 F shell. So it does that version of Linux. I'm not familiar with what that is. There are versions of Linux that don't have systemd. So for example, Alpine won't have systemd init process. So I'm not sure why your system doesn't have systemd, but it also, in order to run that script, it will require systemd, but you could run the command to just download K3s, and then however that operating system does init, you can put it into that version of init.
Okay, thank you. Thanks, Mark.
You're welcome. Taylor asks, what kind of practical use case would I use K3d for? I think practical would be as a developer. I can do local development with a multi-node cluster. So right now, the other options for doing that are the two that I mentioned earlier. What were those? Well, so there's Kube. What was it? There's let's see, MicroK3s and Minikube are the two that you can do local development with, but those are only single node clusters. So if I want to get a sense for multi-node deployment, then I might use K3d in a local development environment. I'd be interested in what other use cases people have. That's the one that I can think of. I'm not sure, K3D. So what K3D is it's running K3s in Docker containers, and there's that extra layer of abstraction by doing that that may not be valuable in like a production use case. That said, K3OS, so the way K3OS works is that it's a container operating system, meaning it has a Linux kernel, and then PID1 is a Docker. It's a system Docker. And then a container is run for user space, and in user space, another Docker process is run. Well, I'm sorry, another container. Sorry, it's containerd, not Docker. So the PID1 is containerd, and then that runs a container, and in that runs another containerd, and you can run K3s then alongside that. But you don't have to have the second containerd. You could run a Docker. Basically, you're running PID1 is your container runtime. And so the indirection of K3D though seems to me as a development. It's practical only for development. And then Ski has a question: if possible, could you show the RPi cluster that you just created from the Rancher UI? So Ski, that's an interesting question. Right now, because let's go back to that cluster. Let's see. So we'll exit out of here, and we'll SSH into this pi at k3s CLF. So right now I can't pull this one into Rancher. And the reason I can't pull this into Rancher has to do with the Rancher agents. So the Rancher agents are currently only run on ARM8 and x86. So if I run it, the Rancher agent that needs to run in order to talk back to Rancher won't run on this system. Now, you may recall that I mentioned way back when, I mentioned that the Raspberry Pi is actually running a V8 chip, right? So, oops, let's see. So this is running ARM V8, and yet when we look at the operating system, it says it's ARM version 7. So why is that? So I'm running Raspbian on this device, and Raspbian is only compiled for 32-bit. So it's emulating the ARM v7 and won't work with Rancher. We could, however, go into say one of the other nodes and pull that into Rancher. So we could pull a K3s node into Rancher. And I don't see any other questions right now, so maybe I'll do that. So let's exit out of here. And oops. All right. So let's go into one of those other nodes. Let's see. And what we can do is we can just right now, remember K3s. Whoops. K3s was installed as a server only. We didn't have the agents on it, and it looks like something's going on with my network. But we could try and install K3s as, and I may run into the same problem here if in fact my security groups are not allowing me to access HTTPS 443 and 6443. I may actually still not be able to do this, but we can try it. We can try and run the K3s as a server and see if we can get anywhere. So skipping service start. Let's uninstall and reinstall just to be sure. Oh, that's the wrong one. No, that's right. No, that's disable agent. We actually want to not disable the agent. Okay, so there we go. So we've got a single node. Let's go into Rancher. We'll add a cluster. I'm going to create an import cluster. Copy this. So what I'm going to do here, so Rancher, as I said, is multi-cluster management. Rancher allows me to pull any upstream Kubernetes cluster into Rancher by running agents on that cluster, and then those agents will talk back to Rancher. They'll set up WebSockets. They'll have two-way communication over the WebSockets and I'll be able to see this cluster in Rancher. So we're going to go ahead and run this. It looks like the agents got created. Oops, get pods. And we'll just keep an eye on that. So it looks like we've got both the cluster agent and the node agent running. And then we'll come back in here. Here it is. And I've got my K3s cluster. I can see I have traffic, the service load balancer, all the same things that I see in kubectl get pods, I'm seeing in here in my workflows. So there it is. All right, so let's take a look. I don't see any other questions. Oh wait, here we go. Okay, yep. I don't see any other questions. So I think that's all I have for today.
Great.
Yeah.
And, thank you, Mark, so much. I'll take the presentation back just to show a last couple of slides for people who might have missed. Let me make sure I share the right screen. And let's put this into presentation mode. Probably it'll mess up what page I'm on. Okay, cool. So just in case people miss this, k3s.io, this is where you can get started, check the GitHub to find the start scripts. And as Mark mentioned, there are several other projects and products that Rancher has been innovating for a while. So K3s and K3s we talked about today, and Rancher as well. But there's also a Longhorn, which I believe is going GA later this year. Rio, which came out not too long ago, and we have a training in a few weeks for that. So there is just a ton of stuff. So please check it out to get to know the Rancher ecosystem to help you get all these Kubernetes clusters at scale and in production. And if you do have further questions, which I'm sure will come up in case you missed this, slack.rancher.io, free user community. Our engineers are on there asking questions, and there is a K3s channel as well as a Kubernetes channel, just lots of other topics that are covered. And there is a survey at the end, so if you are able to stay and fill that out, let us know if there are any other topics or questions that you really wanted us to cover so that we can get better at presenting this material to you all. And if this was a helpful training, reach out on Twitter, let us know. Just we're at Rancher_labs on Twitter, and it'd be great to hear from you there as well. And again, Mark, thank you so much. Have a great rest of your day, everybody.
Thanks, Matthew.